In this section of notes, we're going to review what we learned in Chapter 2 about transforming sets of data, and then apply that to the random variables that we've been studying lately. So in Chapter 2, remember what we did was we took a set of scores and we standardized them. Or in other words, we transitioned them into z-scores. And we did that by making them so that they would end up having a mean of 0 and a standard deviation of 1 by adding and subtracting and multiplying and dividing all of the values by some set numbers. Remember that when we added or subtracted a constant to each value, what that did was it just shifted our dot plot. So the center changed, but the shape and the variability did not. Versus when we multiplied or divided every value in our distribution by some number, it changed both things. It multiplied or divided the center by that same constant, and it also multiplied or divided the standard deviation, but by the absolute value of that constant. So now let's look at an example with, rather than individual scores, let's look at an example with a random variable. So in this scenario, we have Jeep tours and the number of passengers on each tour along with the probabilities. So we could put those into our calculator and find the mean and the standard deviation for the distribution. And then what we want to do is now we want to change our distribution. In this case, if it costs $150 per person to go on the Jeep tour, we take all of our X values and we multiply them all by 150. The probabilities stay the same. And then we can look at our new distribution. We can see it has that same basic shape, although the numbers on the x-axis have changed. So the probabilities didn't change, but the values on the x-axis did. So that means that our mean and our standard deviation are both going to get multiplied by that same value. So we took our old mean and multiplied it by 150, and we took our old standard deviation and multiplied it by the absolute value of 150. So we essentially see that those same rules that happened with our set of data values when we were making z-scores, this all stays the same, and we see the same patterns for working with random variables. So now let's see if that works with addition or subtraction as well. So let's say that we are going to look at the fact that for this business owner, he's got to spend $100 per trip. So that is going to reduce his profit by $100. So we're going to take each of our collected values from the previous problem and subtract $100 each, and then recalculate our shape, center, and variability. So this time we can see that by adding or subtracting, in this case subtracting, that is going to decrease our mean by that same amount. So our mean is $100 less, but our standard deviation has not changed. So that is actually also consistent with what we did back in Chapter 2. So one way we can kind of write both of these things in the same manner is that we can say that if we're going to take our original distribution and we're going to multiply it by some value and add some value, the mean gets multiplied by that same value and added with that same value. But the standard deviation only gets multiplied by the absolute value of the multiplied value. The adding doesn't impact it. Notice that this is similar to Chapter 2, and it now also applies to both discrete and continuous random variables. Make sure you try the practice problems before moving on.